By now you have enough experience with sampling without replacement to know that in successive trials without replacement, probabilities change from trial to trial. That means the trials cannot be independent. Therefore, if a random phenomenon involves sampling without replacement, then it cannot be strictly binomial. Examples of such random phenomena would include random samples of people surveyed in opinion polls, and random samples of products checked for quality control in industry. Even though there might be a proportion overall of people in the opinion poll who believe, or in the population who believe that, are in favor of something, when you go to a sample, as you go through the sample from individual to individual, the probability that the next particular individual is in favor of something would depend on the people in the sample who came before, and that those individual observations in the sample would not be independent. The same thing when you're checking products that come off an assembly line, for instance. If a certain fraction of them are defective, if you check one and it's defective, then the next one is going to be slightly less likely to be defective. And although these changes might be subtle, these changes in the probabilities of particular outcomes might be subtle, they are real, and therefore the successive trials are not strictly independent. So even if the population is quite large in relation to the sample, in situations like these, we're not exactly in a binomial setting. However, here's a little rule of thumb you can use. If the sample is less than 10% of the population, then we can treat the sample observations as approximately independent. And if that's the case, if the other conditions for a binomial setting are met, then we can proceed using binomial methods. We can use binomial probability formulas, binomial mean, binomial standard deviation, and other methods that apply in a binomial setting. So this is what enables us to use binomial methods in situations where, for instance, we're analyzing the results of opinion polls or analyzing samples that are of products that are checked for quality control in industry. And it's very useful to use these binomial methods, and this 10% rule, or independence condition as we call it, is the key to being able to do that. So we're going to encounter this a lot when we go through the rest of the unit on binomial distributions, and then later on when we study statistical inference for proportions. This is going to be very important. So it's worth its own video